Hello, everyone. All right, we'll make this quick and painless. So this is sort of disruptive technologies, and why in the hell would a data center person be talking to you guys, an HPC user community? And particularly, why would somebody be talking about Iceland in Tucson? Very simple. We're not an HPC user. We're a co-location company in Iceland, and most of our customers are employing HPC technologies. They bring their HPC gear to our site, so we have to ask ourselves the question, why? What is driving them to make that move? Throughout this conference, what I've been hearing over and over again is emerging technologies and how fast your industry is growing. So from artificial intelligence to computational fluid dynamics, crash test simulations, all of these are HPC applications, and they belong in the most optimal of locations. And that is why I'm going to talk to you about Iceland in less than 10 minutes. The biggest constraint that your industry and most supercompute HPC type applications have is power. You're going to be limited by power because Intel is doing great things at making the chip more efficient. But the number of chips that you guys are using is multiplying exponentially, and it'll be more and more of them. I go to these conferences, particularly with HPC, and you guys are talking in the multi-megawatt deals, meaning your monthly electric bill is over $1 million. So any kind of savings goes right back into your pocket to do more research, to do more analytics. So in the case of Iceland, they're tapping 10% of the energy that is available to them by nature. I'll give you a comparison. In the UK, there's a 4% gap between supply and demand. They're having to import what they cannot produce within themselves. Goes across the channel from France. Well, guess what? 50% of European power is imported from even further to the east. Think Putin and friends. So unstable. Here you're talking about an island in the middle of the North Atlantic. There is nothing to import, there is nothing to export. So barely tapped, plentiful and abundant. Not only that, but it's stable. It's ranked number 2 in the world behind Singapore in terms of the stability of the power. Where else can you get 99.99, 4 nines of availability just from your utility grid? Never seen an outage. Most of the friends that work in our company that live in Iceland, they've never seen an outage. They don't know what an electrical outage is. I'm not talking about a second or an hour or a day. It just doesn't happen. Why? Because it's new. 50 years ago, they were shipping coal to Iceland. It's all new, it's all robust. It's meant to be there for generations. Thirdly, it's scalable. And not only that, but the fact that you can tap into the sources that are there in abundance. You're talking about gigawatts worth of power that are just there waiting. Wells, geothermal wells, that you can just press a button and you're getting 10 megawatts worth of power. It's all there, readily available for them to tap on. It's, again, relatively new, less than about 40 years, and it's very evenly spread across the country. Our data center is located at the very, very, very southwestern tip of Iceland, ex-NATO base in terms of site selection. One of the presentations that we saw earlier talking about Europe, it's too bad the Germans are probably long gone on their taxi, but there's a vast difference in price when it comes to electricity between continental Europe and Iceland. There's also a big difference between even the Columbia River. Think, eastern Washington State, Utah, all the places that we're now going to build our data centers. Iceland, not only is it a lot cheaper, but because there's no imports and exports, you're not talking about a commodity traded on the market. We can sign contracts with our customers to say this will be your power bill 10 years from now, 15 years from now. I challenge anyone to do that with your local company here in the US. Impossible. I told you that you guys are dealing in megawatt type applications, so let's take 1 megawatt worth of load over a period of 10 years. That's a little bit over $3 million in terms of operations in Iceland. Go to London, 17. Places that we're going to now. Where did Apple just went to? North Carolina, Charlotte. You're talking about 7. Half of that if you go to Iceland. So there is a logic and a reasoning behind it, and it's very straightforward. Your largest operational cost is power. You free that money up, you can buy a lot more stuff. You can do a lot more with it. I don't think I need to reemphasize the fact that Iceland is cold, but it's not as cold as you would think. So as scientists and engineers, focus on the minimum temperature. These are obviously degrees centigrade. It's not as cold as you would think. Boston is often a lot colder in the winter. Most of our customers, I'd say about 70%, are from Europe. CO2 emissions and social responsibility towards the environment is huge, and you actually get penalized in certain ways in certain countries. So your CO2 emissions are something that they look at closely, hence the move to the Nordics. Connectivity has to be there for what it is that whatever application it is that you're doing, but in Iceland right now, today, the yellow ones, are 3 existing underwater sea cables. All of those cables terminate in our facility. There's another one being built right now. It's 70% done from New York to Dublin, and that'll have a spur going over to Iceland. I want to give you an example of a customer. As I said, our customers are bringing their HPC applications to us. So one of the things that I heard was crash test simulations. Well, guess what? BMW, a couple of years ago, 2012, they moved all of their HPC gear. Everything that they were doing, so take their entire data center, 20% of it was HPC, they moved it all to Iceland. They never told their auto engineers in Munich that they were doing this, because they kind of wanted to see the latency, and we did latency testing before. Guess what? They never saw the difference, and over a period of a year, we did a case study. I invite you to go to our website to take a look at that case study, but 82% savings in energy cost. That's an amazing figure, and that's what they were able to accomplish just by moving their HPC footprint. So we're not talking about moving everything you do, moving your entire infrastructure. Think about what it is that you're doing. Think about this mission-critical world that we all live in, and think about what your mission really is. And your mission is to advance forward, to move forward, and you do that by liberating funds that you can use elsewhere. Carbon, as I said, is very important, and then we translate it into actual fuel consumption. So not bad. I got 2 minutes left. So this is my last slide. Thank you very much, which will be happily handed back to the crowd, or I'll take questions if there are any. Thank you.